Okay, Chapter 9 review, Part 2. Number 1, write an equation in standard form with polynomial of least possible degree with these roots. You need to turn these into roots. First of all, x equals 2 is x minus 2 as a factor, and x equals 3i is x minus 3i as a factor. If you include x minus 3i, you have to have its conjugate, x plus 3i. Now, since this says standard form, we have to multiply these out. I would suggest multiplying the imaginary parts first, foiling them, which will give you x squared, and then the middle parts cancel out. Negative 3i times positive 3i is negative 9i squared, which is positive 9. Then we're going to FOIL that with x minus 2. When you FOIL this, you get x cubed plus 9x minus 2x squared, and then minus 18. To get it in standard form, I need to write it in order of degree. X to the third minus 2x squared plus 9x minus 18. That is standard form. F of x equals, of course. Number 2, given the graph, how many zeros are real? You have one real here, and since that touches the graph, that's 2. It has a multiplicity of 2, so you have 3 real zeros. How many zeros are imaginary? We have to figure out this line that crosses through it the most. That line would go through 1, 2, 3, 4, 5, 6, 7 times. So if I have 7 total zeros, 3 of which are real, there are 4 imaginary zeros, and the least possible degree is 7 for the reason of the horizontal line. Number 3, building a polynomial with these zeros. It tells you your zeros and tells you the multiplicity. Negative 2 becomes plus 2. I'm going to start this off as f of x, of course, since it's a polynomial. F of x equals x plus 2. It has a multiplicity of 1, so I don't need an exponent. Negative 1 has a multiplicity of 2, so that's going to become x plus 1 with an exponent of 2 because of the multiplicity. 5i, I'm going to have to do x minus 5i to the power of 3, and x plus 5i to the power of 3. And 3/4, that of course becomes 4x minus 3, has a multiplicity of 1, so no exponent. Number 4, if q is a polynomial and q at negative 7 equals 0, the following, negative 7 is called a solution. It's also called a 0. You might call it a root. What does it mean? It means that the polynomial has a value of 0 when x equals negative 7. Factors, negative 7 as a factor would be x plus 7. Number 5, we went over this in class. What's missing? I'm going to run through it quickly. X minus 3i, that means you have to have x plus I. If you have an imaginary part, you must have its complex conjugate as well. How many x-intercepts does this have? In order to figure that out, we have to factor these into linear factors. Okay, so I'm going to write out the parts that already are linear factors. Well, they already are written. Let's go ahead right here and just turn these into linear factors. I would plug them into the quadratic formula and find that this is x minus 5i and x plus 5i. And this one, in the quadratic formula, I had it right there, 1, 3, and negative 2 gives you 0.56, so this would be x minus 0.56 and x plus 3.56. So now it's factored. These two are factored. These ones were already good. So you're good to go. How many x-intercepts does it have? It has an x-intercept at 0, so that's 1. It has an x-intercept here, that's real, at 3 over 2, so that's a second one. This is imaginary, so it's not an x-intercept. This is imaginary, so it's not an x-intercept. These two are imaginary, so they're not x-intercepts. And these two are real, so you have a total of 4 x-intercept. Find all zeros of f and list their multiplicities. First of all, that should be their multiplicities. 4x gives me a 0 at 0, so I have x equals 0 with a multiplicity of 1. Again, this, if you're struggling with this, it's 3 minus 2x equals 0, and you solve for x. So you subtract 3. Negative 2x equals negative 3. Divide by negative 2. You get x equals 3 over 2. So I have x equals 3 over 2 with a multiplicity of 2. Again, the reason that the multiplicity of 2 is because it has an exponent of 2. I have a 0 at 3i, x equals 3i with a multiplicity of 1. X equals negative 3i, again that came from this, with a multiplicity of 1. I have 5i and negative 5i. Again, both with a multiplicity of 1. I'm not going to write it. And then over here I found these roots, which are decimals, but still I have x equals 0.56 and x equals negative 3.56. Those are all my zeros and their multiplicities. Everything is 1 except for 3 over 2 based on that. On the back page, similar question to the other side. We have this polynomial. Does f of 3i equal 0? What you're going to need to do is plug it into your calculator. I have 6 times 3i to the 5th minus 11 times 3i to the 4th plus 50 times 3i to the 3rd minus 95 times 3i squared minus 36 times 3i plus 36. Does it equal 0? Well, if you look at this, it's 3 times 10 to the negative 11th, which is so tiny, and 1 times 10 to the negative 10th, or 1, yeah, I. That's 0. So I would say yes, absolutely. That equals 0 for all intents and purposes. Now, it asks if negative 1. All I'm going to do is go back, and everywhere there's a 3i, put a negative 1, and I'm going to find out. No, it does not equal 0. Negative 1 plugged in for x equals negative 90. No. And then, of course, 2, I'm going to do the same thing. Second enter, pop it back up here. I've got delete 2, delete 2, delete 2, delete 2, delete 2. Does that equal 0? You bet it does. So this is yes. Find all zeros. Let's graph it. Y equals 6x to the 5th minus 11x to the 4th plus 50x to the 3rd minus 95x squared minus 36x plus 36. You see there you have 3 zeros, okay? You have 3 zeros and we need to go find those. So I know I have a 0 at 2. I'm going to zoom in to go find the other one. So zoom in. I'm going to go find these zeros. This one is, well, let's double check. Second trace, 0. Let's find this one. Left bound is negative 1, right bound is 0. Guess is negative 2/3. And finally the other one is 1/2. You can second trace that one, you get 1/2. I'm going to zoom out and make sure that there's no more real zeros. I messed that up. And I just have those 3. That means my other ones must be imaginary zeros. So what you have to do here is do the synthetic division by each of these. I'm not going to go over this on this because it'll take too long. Again, you'd put 2 in a box and put your coefficients next to the box. Find the conjugate of this. First, we want to find what this is. So we're going to distribute the 2. We've got 3 plus 4i minus 8 plus 6i. Combine 3 plus negative 8 is negative 5. 4i plus 6i is 10i. So that's what this equals, but we want the conjugate of that. Conjugate of it would be negative 5 minus 10i. That's your answer. Number 8 we didn't need to do because that slipped on here from the last part of chapter 9. This one, 3i is called a 0. It's a complex 0, but it's a 0. What does the 0 mean? It means that when you plug in 3i into the equation for the polynomial, your answer is 0. It comes out to be 0. Factors here, you would have x minus 3i, and because it's complex, you'd also have x plus 3i. For number 10, to the nearest tenth, approximate the largest x-intercept. All you need to do for that is plug this into your calculator. 2x to the fourth minus 5x squared plus 3x minus 5. And go look at the graph. I'm going to zoom in a little bit. Actually, I'm just going to set my window back from negative 10 to 10. And I'm going to graph it. I can see my largest intercept is right there. So I'm going to go second trace, 0. It looks to me that it occurs between 1 and 2. So I'm going to say left bound is 1, right bound is 2. Guess, I'm good. And you'd answer 1.59 or 1.6. About 1.59. Okay? For the progress self-test, we talked about this a little bit earlier. Really the biggest part of the progress self-test that I wanted you to do and know is if I have this formula, g of x equals x minus 8 cubed times 2x minus 3 squared times 5x minus 1, it asks you what 0 has a multiplicity of 2? Well, that'd be this 0. So what 0 is that? Well, 2x minus 3 equals 0. Add 3. 2x equals 3. Divide by 2. So the 0 that has a multiplicity of 2 is 3/2. That would be the answer to that. Next question says, what is the degree of this? This has degree 3 plus 2 plus 1. The degree would be 6. Okay, and number 10, how many x-intercepts does the graph have? 1, 2, 3. You still, even though you have a degree of 3, or of 6, and you have 6 zeros, you still only have 3 x-intercepts, okay, because multiplicity don't really come into play there. All right, that is what you needed to know. Email with questions or talk to me in class tomorrow.